Alright, so today this is topic 6. What we're going to talk about is writing equations in word problems, or analyzing them as well. So in word problems, even though it's in a context, you'll still be given essentially what is either the slope and the y-intercept, or you may be given the slope and a data point, or you may be given 2 points, or 2 pieces of data which tell you 2 points are 2 coordinate pairs. Alright, so then you can figure out your equation and apply it to the problem. So in this first one, Mr. Kimball receives a $3,000 annual salary increase every year after he's hired, as long as he gets a satisfactory performance review. His starting salary was this. So the slope is always going to be what changes, and the y-intercept is going to be the starting amount for whatever we're talking about, or an initial cost, or some initial or starting value. Now, if they give us a point, we're going to have to figure out what our x's and y's are and see what numbers go with each of those types of quantities. So for this one, they actually give us the slope and the y-intercept. Alright, he receives a $3,000 annual salary increase. That means every year his salary changes by a positive $3,000. So we have y equals positive 3,000 times every x, so for every year. So he works at 1 year, up by 3 grand. 2 years, 6 grand more than he started with. Plus our y-intercept. Here our starting value is 41,250. So that is our equation right there. If we wanted to know how much he made after a certain number of years, we just plug it in for x. A couple more examples here. So to sign up for a music class, registration fee is $25. So how many times are you going to pay that? Just once. So this is our starting value. That's the b in our equation. So we're looking for a y equals mx plus b type equation here. And then after that, you pay $85 for 6 classes. Write an equation that represents the total cost C. So that's our y is now going to be C, and for n classes. We use C and n because those letters make more sense for our problem. Since we're talking about cost, we're going to let our variable be C for cost. And then the slope times, instead of just a random x, n, because n stands for number of classes, plus our y-intercept. So we're still looking for the slope and the y-intercept. We still want these numbers. Okay, now they gave us, here our y values are the money, and the x values are the number of classes. So they give us one data point right here. So we have our starting values, so we know that the y-intercept is 25. So we know it's C equals something times n plus 25. The way we figure out our slope is we use this data point. So for 6 classes, it's $85. Making sure you have the right number with the x and the right number with the y is important. Now we just plug that into our equation. So we know that it's y equals mx plus b, or cost equals slope times n plus b. We have all 3 of these numbers except for the slope. So let's plug all the numbers in. The total cost is 85 equals whatever the slope is times the number of classes is 6 plus $25. So we've plugged everything in, and we just have to solve for the slope m, and then we'll know what this needs to be. So minus 25. So now our slope is 10. So that's what goes here. This is our equation. Cost is $10 per class plus $25. If we want to find out the cost for 12 classes, then we can just plug that into our formula. So it would be the cost equals $10 per class times 12 classes plus 25, which gives us 120, so 5 is $145. There we go. So that was the y-intercept, and 1 point is what they gave us. So So for this one, the cost for 8 gymnastics classes or lessons is $94. The cost for 12 lessons is $138. Write a linear function to find the total cost. So we want C equals for L lessons. Then use the equation to find the cost of 5 lessons. So first we need to find some sort of equation that looks like this. Again, we've changed the variables to be more appropriate for our problem. So the cost is equal to the slope times the number of lessons plus the initial cost plus the starting value b. Here we have 2 points. We have 8 classes goes with $94 and 12 lessons goes with $138. Our cost is our y, so that's our y, and the number of lessons is our x. So we have 8 lessons for $94 and we have 12 lessons for $138. Now this is exactly the same as the type of problem that we did before when you get the equation, a y equals mx plus b equation, given 2 points. You have to find the slope and then solve for the y-intercept. So here we do that. The slope is this. So our slope is 11. And then so we have C equals something 11L plus some y-intercept. Now we plug in our values that they give. Doesn't matter, I'm going to use this point. Could use either point. So I have 94 is my cost equals the slope 11 times the number of classes plus the y-intercept. So 94 equals 88 plus b, and that means 6 equals b. So this is our function. The cost is 11 times the number of classes or lessons plus 6. If we want to know how much 5 lessons cost, we just plug it into our formula. C equals 11 times 5 plus 6, which is 55 plus 6, which gives us 61. So the cost of 5 lessons is $61. Now this next part is not necessary to do the problems. This is just another helpful way to check and see if you've done them correctly. Also, it's a good idea to make sure that it makes sense. So our cost is dollars, right? We have cost equals 11L plus B. Our slope is dollars per number of classes. The thing we're plugging in, number of lessons or number of classes, that's a number. And then the initial value is a dollar amount. So when we simplify, not worrying about what the numbers are, just what the units are and seeing if they make sense, dollars equals numbers over numbers cancel. So dollars amount equals some dollar amount plus a dollar amount. So that makes sense for units. If you didn't get this last part, don't worry about it. I can explain it in class. So we got a couple more problems, but here's your U-try that are very similar to those. And then here's a couple more problems interpreting what you're given once you have the equation. So the graph to the right shows the distance remaining to complete a tunnel. Okay, so as time goes on, they dig more of the tunnel, so there's less distance remaining to dig. Write an equation that represents the distance. So we want y equals mx plus b. Y is the feet remaining, our y. X is the time that's gone on, so x is time. So we need the slope. All we do is we just, since they give us these 2 points, let's use these 2 points. Do rise over run. Here, we can actually do this in our head. The rise, or the change in y, right? Our slope is change in y over change in x. Here, the change in y is from this point to that point. Now, it only goes down 4 boxes, but each of those boxes represents 500. Or you can see it goes from 3,500 to 1,500, and that's a change of negative 2,000. It goes down 2,000. And then it goes over 4 months. So it's a positive 4 for the change in x. So that simplifies to our m is a negative 500. 2,000 over 4 is 500. So y equals negative 500x plus our y-intercept. Well, the y-intercept is just right here. It's where it hits the y-axis. And that's at a value of 3,500. So that is our equation. So find the x-intercept and interpret its meaning in the context of the problem. So throughout this, it's a really good idea to think of what does the x stand for and what does the y stand for. Here, our x, y's stand for, the x is time, and the y is feet, or feet left to dig. So here, the x-intercept is when time is 7, and there's 0 feet left to dig, right? This is time, and this is feet. So that means after 7 months, there are 0 feet left to dig. So they're done the tunnel. The tunnel took 7 months to dig. So that implies that it took 7 months to dig the tunnel. That's it. So find the y-intercept and interpret it in the context. So the y-intercept is right here. We already knew that. So 0, 3,500. That's when time was 0, and the feet left to dig was 3,500. So time is 0 tells us they haven't started yet. And 3,500 is the feet left to dig. Which tells us that the tunnel is a full 3,500 feet long. So see how understanding what the numbers correspond to in the context of our problem can help us discover or find out or explain a lot more about a given situation or problem. So here's your U-try on that. Oh, just kidding. More examples. This is your U-try. So let me do a couple more examples. The amount in gallons of gasoline, so that's our Y. So this is going to be gallons. Sorry for not writing nicely upside down, or sideways. Gallons in gasoline remaining in a gas tank after driving X hours. So this is time, and that's in hours. So let's make up a scale that makes sense. I need to be able to fit 12 on this Y, because my Y-intercept is 12. So I'm going to go up by ones, I think. It will only fit. So that's 2, 3, 4, 10, and there's 12. So that's my y-intercept. And then for time in years, I can make it a little longer. So we'll do 1 year, 2, 6 years. So now I want to plot my graph. Y equals negative 2x plus 12. So we start at a y-intercept of 12. And we go down 2 over 1. So I actually have to go over this far to go 1 unit. So down 2, it's down to the 10, over to 1, there's my next point. Down 2, over 1, continue the pattern, and there is our line. Notice that I put gallons of gas on the y-axis. I labeled the x-axis as well, so you want to label your axes, make up the correct scale. It says interpret the x and y intercepts. So the x-intercept is down here. That's the point 6, 0. And remember, our x's stand for time. So that's time. And this is gallons left. So that means after 6 hours, the tank is empty. And then for our y-intercept, that's 0, 12. So the 0 is for our time, says we haven't driven anywhere yet, and that tells us there's 12 gallons of gas left. So it's a 12-gallon tank. If you've driven nowhere, then that's 12 gallons in the tank. Alright, so last example here. The average lifespan of an American woman has been tracked, and the model for the data is this equation, y equals 0.2t plus 73. Where t equals 0, if we plugged in a 0 here, our y-intercept would be 73. T equals 0 corresponds to the year 1960. So any other number for t would just be how many years after 1960. So the y-intercept is 73, and that tells us at 0 years, or 0t, so in 1960, the life expectancy for females was 73. That's for women in the U.S. Alright, so those are a few more examples of interpreting the equations. Here is your last U-try, and if you have any questions, be sure to jot them down in the margins, and we'll see you next class.